In this episode, we're going to build a beginner-friendly foundation for 3 ideas that show up constantly in security operations and management: cyber defense theory, threat intelligence, and defensible architecture. When people first hear these phrases, they can sound like separate academic topics, but they actually fit together like parts of one story. The story is about how attackers think, how defenders decide what matters, and how systems are designed so that mistakes or attacks do not immediately turn into disasters. If you learn these concepts as isolated definitions, they will feel abstract and hard to apply, especially on an exam that expects judgment. If you learn them as a connected set of mental models, they become practical tools for making decisions and explaining why a security program is built a certain way. That connection is what we are going to focus on, using plain language and simple examples that help you see how these ideas work together. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Cyber defense theory is basically the set of ideas that explains how defense works when an attacker is actively trying to win. Defense is not like locking a door in a quiet neighborhood and assuming that is the end of the story, because attackers adapt and look for the weakest path. Theory helps you stop relying on hope and instead rely on patterns, because the same types of weaknesses and mistakes appear again and again across different organizations. One core idea is that defense is layered, meaning you do not depend on a single control to stop everything. Another core idea is that defense is risk-based, meaning you cannot protect everything equally, so you prioritize what matters most. A third core idea is that defense is a cycle, meaning you prevent what you can, detect what you cannot prevent, respond to what still gets through, and then improve so the same failure is less likely next time. A useful way to make cyber defense theory feel real is to think of it as answering 3 questions. What are we protecting? What could go wrong? And what do we do about it? What we are protecting includes data, systems, people, and the organization's ability to operate. What could go wrong includes technical failures, human mistakes, and intentional attacks, and it also includes the chain reactions those events can cause. What we do about it includes policies, training, monitoring, and technical controls, but also includes communication and decision-making. Theory matters because without it, defenses become random, with gaps you cannot explain and investments you cannot justify. With theory, you can explain why certain controls exist and how they work together to reduce risk in a repeatable way. Threat intelligence, TI, is information that helps you understand the threat environment so you can make better defensive decisions. It is not magic prediction, and it is not a list of scary headlines meant to create fear. It is meant to help you answer practical questions like which threats are most relevant to your organization, what tactics attackers are using, and what indicators could help you detect activity. TI can include many kinds of information, from broad trends about attacker goals to specific technical clues that can be used for detection. The key is that it should be actionable, meaning it should change what you do, not just what you know. When it is used well, it helps you prioritize your attention and resources toward threats that are likely, impactful, and relevant. Beginners often get confused because TI comes in different levels, and the levels serve different purposes. Strategic intelligence is high-level and helps leaders understand major risks and trends, such as shifts in attacker focus or changes in the broader landscape. Operational intelligence is closer to real activity and helps defenders understand campaigns, methods, and how attackers might target certain environments. Tactical intelligence is even more specific and often includes details that can support detection, such as patterns, tools, or technical artifacts. None of these levels is automatically better than the others, because the value depends on what decision you need to make. A manager might need strategic context to justify investments, while an operations team might need tactical details to tune detection logic. Understanding these levels helps you choose the right type of intelligence for the right purpose. Now let's connect defense theory and TI, because they are strongest when they work together. Defense theory tells you that you must prioritize and layer controls, but it does not tell you which threats are most likely for your specific environment. That is where TI helps, because it can highlight which attacker behaviors are common, which vulnerabilities are being exploited, and which kinds of targets are being pursued. In other words, theory gives you the framework, and intelligence gives you the current context. Without theory, intelligence becomes a pile of facts with no clear use. Without intelligence, theory can become generic and disconnected from the real world. When you combine them, you can say something like, "We will strengthen detection for this behavior because it is currently being used against environments like ours, and we will add a control layer here because it reduces risk even if one control fails." Defensible architecture is the design of systems so that they are easier to protect, easier to monitor, and harder to break in ways that cause major damage. Architecture is about structure, meaning how components are arranged and how they interact. A defensible design accepts that bad things can happen, so it tries to limit the blast radius, which is the scope of damage that can occur from one failure. It also tries to increase visibility, meaning defenders can see what is happening and investigate quickly. Another important part is reducing unnecessary complexity, because complexity creates hidden weaknesses and makes monitoring harder. The idea is not to create a perfect fortress, but to create a structure where risk is controlled and where defenders have a fair chance to detect and respond. A simple analogy for defensible architecture is the difference between a house with one flimsy door and a house with a sensible layout, locks, lighting, and clear lines of sight. If every room in a house is connected by secret passages and there are no lights in the hallways, it becomes hard to notice an intruder and easy for them to move around. If the house is organized with clear entry points, limited access to certain rooms, and a layout that makes movement visible, defense becomes more practical. In computer systems, the same idea applies when you separate critical systems from less critical ones, restrict access paths, and ensure important actions are logged. Defensible architecture is often invisible when it is working because it feels like normal organization. When it is missing, everything feels fragile, and small issues turn into big incidents. This is where the word defensible matters, because it implies you can justify the design choices and show evidence that they reduce risk. Defensible does not mean unbreakable, and it does not mean that attacks never succeed. It means that when you explain your design to a reviewer, a leader, or even yourself, the choices make sense given the threats and the goals. It also means that when something goes wrong, the design supports investigation and recovery rather than making them impossible. For example, segmentation can be defensible because it limits how far an attacker can move, and logging can be defensible because it provides evidence. Those choices connect back to defense theory because they create layers and reduce risk, and they connect to TI because intelligence can inform where segmentation and monitoring are most valuable. A common misconception is that defensible architecture is only about network diagrams and infrastructure design. In reality, architecture also includes identity, access boundaries, data flow, and the operational processes that keep systems trustworthy. If the design allows anyone to access critical systems without strong checks, the architecture is not defensible even if the network looks neat. If data moves through systems without clear ownership and classification, the architecture is harder to defend because you cannot tell what matters most. If monitoring is bolted on as an afterthought, defenders will struggle to see important events, which makes response slower and less accurate. A defensible approach thinks about protection and visibility from the start. That is why architecture is a management concern, not just an engineering concern. When you bring all three ideas together, you get a practical decision loop for security operations. Cyber defense theory tells you to build layered, risk-based controls that assume some failures will occur. TI tells you which threats and behaviors deserve extra attention right now and how attackers are likely to approach targets like yours. Defensible architecture gives you the structural foundation that makes controls and monitoring effective rather than fragile. Together, they help you prioritize, because you can say which assets matter most, which threats are relevant, and which design choices reduce the chance that one mistake becomes a catastrophe. They also help you explain decisions, because you can link investments and policies back to clear reasoning instead of vague fear. That ability to explain, prioritize, and design is exactly what security operations management is about. To keep these ideas clear in your mind, focus on the questions each one helps you answer. Defense theory helps you answer how defense works and why layering and prioritization are necessary in a world where attackers adapt. TI helps you answer what is happening in the threat landscape and what patterns or indicators can guide your decisions. Defensible architecture helps you answer how to build systems so that protection and monitoring are practical, damage is limited, and recovery is possible. If you can explain those roles and how they connect, you will be able to handle many exam questions that test judgment rather than memorization. These concepts are not meant to intimidate you with complexity. They are meant to give you a stable framework for thinking. When you hold that framework, the rest of the course builds naturally on top of it, because you will keep returning to the same story of threat, decision, design, and improvement.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.